Hello dear students, this is a mathematical model in which we are going to try to understand what is the meaning of model, what is the meaning of mathematical model, what is the process of mathematical model and example based on mathematical models. Myself Professor Vaishali Bharat Gholam. Okay, introduction. Mathematical model. Before we are going to understand what is meant by model. Model is replication of something which is happening in the real. Okay, or we can say model is a miniature or abstract representation of something, or we can say a pattern of something to be made, or representation used to visualize something, that we call it as a model. We observe that there are three types of model: physical model, schematic model and mathematical model. Physical model, you all know that prototype of model, or we can say the constructed type of model. For example, tractor model, aeroplane model, solar system model, building model, which will give us the what will be the abstract model or miniature of our real model. Okay, that is the physical type of model. Another type of models are schematic model. Schematic models are mainly made for visualizing the system. For example, organization structure, diagram, map, geographical representation. These are called as schematic model. Another model is mathematical model that we are going to see in detail in this video. Mathematical model is the representation of behavior of real object and phenomena in mathematical language. As we have already studied in this subject, that algebraic equations, differential equation, integration or integral, different formulas, theorem, these are nothing but the models. Okay, that's why mathematical model is a mathematical description of real life problems. Okay, and what is the mathematical modeling? It is the process of creating a mathematical model, solving it and using it to understand the real life problem. These are the different steps we have to follow while preparing the or making the mathematical model with some example. First step of mathematical model is understanding the problem. Okay, how we can understand the problem? For example, if we are working in a team, okay, at that time there are some issues occur. First of all, we need to understand the issue, simplify that issue with the assumptions and ignore certain factors and make the problem manageable. Okay, for example, okay, here we take the example that we need to estimate the number of fish in lake. Okay, it is not possible to capture each of these fishes and count them because it is impossible. For that purpose, we first of all identify the problem and then find out some solutions. Here we find out the solution, we take some samples and from that sample we try to estimate what will be the total number of count of fishes or population of fishes in that lake. Okay, that is first step, understanding the problem. Second step of mathematical modeling is formulating the mathematical model. How we can formulate the mathematical model? See, the mathematical term, we try to describe that problem in a mathematical way or mathematical language. What are the different mathematical language? We can use the graph or we can tabulate the data, try to formulate or represent that data in equation or formulas, or we can say graphical representation. These are the different tools through which we formulate that model, that physical or real life problem into the mathematical model. Here we use different variables, various equations, gather the information or data, organize in a tabular form. Also we make the graph, we calculate the probability. These are the different ways through which we formulate the mathematical model. Again, here we take the example of we want to find out the number of fishes in the lake. How we can formulate the mathematical model for it? See, we have decided that we take some sample. From that sample, we estimate the population of the fishes in that lake. Okay. First of all, we take sample. From that sample, we mark the fishes. Okay. Again, with that sample, put into the lake and again we uniformly distribute. We see that the all fishes we have marked uniformly mixed in that lake. Again we take the sample and see how many of the previously marked ones are presented in the new sample. Likewise we repeated this process. For example, we repeated this process for 20 times. Okay, we take the 20 samples and we take the 20th sample, we get we repeated this process for example 50 times. At 50th time we get the sample of 5 out of 50 fishes. We get 5 mark fishes out of 50 samples. Then what will be the population? We can predict 1 by 10. If we take 10 fishes from the sample, we will get 1 mark fishes. Means from this we can say that we can predict some population of that fishes in that lake. This is the stage of formulating the mathematical model. Okay, but here we have to make some assumptions. Based on that assumptions, we are going to predict something. That assumption is the marked fishes mix uniformly with the remaining fishes. That is the assumption. So that we can we take the sample which is good representation of the entire population. That is the formulating the mathematical model steps. Third step is solving. Here we have fixed that mathematical model. Now we have to solve that mathematical problem. Okay, how we can solve that? Means here we simplify the mathematical problem. Okay, using various mathematical techniques. Okay, here in second step, means in this formulating the mathematical model, we take the samples of the fishes. Fishes mark are 5 out of 50, means that is 1 by 10 of the population is marked. If this is the typical of the whole population, then we can say that the population of the fishes in the lake will be 20 into 10, that is 200 fishes will be available in that lake. That is the solving the mathematical problem. That is the third step. Now fourth step, here we interpret the solution. Means here we interpret the solution, means what we calculated in the previous step is look at and in context of real life situation that we had started within the step 1. Okay, for example, our solution in the problem in step 3. Okay, step 3 gives us the population of fishes is 200. That is interpreting the result. We have interpreted the result because we will get the same result when we draw the sample. Means here we interpret the result. There are near about 200 fishes in that lake. That is interpreting the result. Then last step is validating the model. Okay, here we go back to the original situation and see if the result of the mathematical work makes sense or not. Here that is a validation stage. Okay, if so we use the same model until the new information became available or assumptions change. If that is not valid or that is not matched with the real situation, then again we have to repeat all the steps. Either we can start with understanding the problem or we can start with the reformulating the mathematical model. This is the steps of mathematical modeling. Here I have given in the diagram form the steps of mathematical modeling. That is, first of all we have to understand the real life problem. Then we modify that real life problem in the mathematical term, means describe the problem in a mathematical term, then solve that problem, then based on that solutions we interpret the solutions, then we compare that solutions with the real situations. If it is true, then we use that model, or we can say the model is suitable. If that result are not matched with the real life situations, then we repeat the step. Either we start from starting stage or we can start with the second step, that we can modify the or formulate the mathematical model. This is the process of math or steps of mathematical modeling. Then what are the different example of mathematical model? Here I have given some example that we can, using the mathematical model, we can predict the arrival of monsoon in the country, estimating the number of leaves in a tree, estimating the effect of pollutant on the environment. Likewise, we can use the mathematical model for predicting. Okay, now what is the importance of mathematical modeling? One and most important importance of mathematical modeling is to gain understanding, or we can analyze the problem, or we can analyze the situation. The most important point or objective of mathematical modeling. Okay, here we try to analyze the situation, or we try to understand the behavior pattern That is first, to gain the understanding of the real situation. Then in second stage, we predict, or we can say the forecast or stimulate the result. Okay, we wish to know, every time we wish to know what will be the uh, future prediction of that situation. For example, we want to predict the weather predict, or we want to study the drug efficacy in human, or also we want to find out what will be the future market price of some stocks. That is the prediction or forecasting. That is another most important use of mathematical modeling. Based on the previous data behavior, we study or predict for the future by fitting that past data in a specific model, and based on that model we predict for the future. That is second importance, that is to predict or forecast. And last and most important use or importance of mathematical modeling is to estimate. Okay, here estimate means, for example, we want to find out or know the trees in forest, fishes in lake here, or also another example is the politicians want to know what will be the probable votes they will get after winning the elections. Okay, these are the example of to estimate based upon the survey or situations or proper understanding. These are the three most important uses, or we can say the objective of mathematical modeling. Now we are going to see there are three different types of model: linear, quadratic and exponential model. Here you can see the standard form of linear equation, that is y is equal to mx plus b. Okay, quadratic equation standard form is y is equal to ax square plus bx plus c. Exponential equation is y is equal to a b raised to x. Then based on this, or if we have given the data, how we can predict which type of model is suitable for that data. See, if the first difference of the dependent value is same, the model will be linear. If the second difference of the dependent value is same, the model will be quadratic. Third, if the ratio of the dependent value is same, the model will be exponential. This we are going to see in actual example in next slide. See, here we want to determine which type of model is suitable for this given information. We have given the x value and y value. How we can determine? See, these are the x means independent variable, y means dependent variable. Here we find out the difference of y, or we can say output, and this x is input. Okay, we find out the difference of y value. If the difference, you can see 8 minus 5, 3. 5 minus 2, 3. 2 minus 1 means 2 plus 1, 3. Minus 1 minus 4, that also 3. Means here the first difference, the difference between any two successive output value is the same value, that is 3. This means that data can be molded using linear regression line. The equation to represent the data is y is equal to 3x plus 2. Here we can use the linear equation because the difference between the successive values of output is same. Another example, this information is given, and we have to tell which type of model is used for analyzing this data. X is input, y is output. Okay, here we find out the difference of y values. 55 minus 36, 19. 36 minus 21, 15. 21 minus 10, 11. 10 minus 3, 7. 3 minus 0, 3. 0 minus 1, minus 1. Here there is no same, there is a difference in the difference of the y values. Now again we find out the difference of difference, that is 19 minus 15, 4. 15 minus 11, 4. 11 minus 7, 4. 7 minus 3, 4. 3 minus 1, that is 4. Here the second difference is the same value, that is 4. This means that data can be molded using quadratic equation. See, when the difference of difference is same, here we can fit the quadratic equation or quadratic function. Next, determine the model for the given data. X value means input value is given and output value is also given. Okay, here you can see that we cannot say that the difference will be same because values are different. Now we find out the ratios. Okay, 325 by 108, 3. 108 by 36, 3. 36 by 12, 3. 12 by 4, 3. Means your ratio of y values is same. The ratio of values between each set of number is same, that is 3. This means that data can be modeled using exponential equation. The equation to represent the data is y is equal to 4 into 3 raised to x. This is here we can use the exponential function to fit the data. Now example, determine whether the data is best fitted by linear, quadratic or exponential function. Okay, these three type of data is given. First is x and y values given. Means for what we need to first find out the difference between successive x values, that is 3, 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11. Means there is a addition of 3. Repeatedly adding 3 we will get the next value for x. But based on output value we can predict which type of model we can use. You can see here 1 minus 2 minus 1, 2 minus 3 minus 1, 3 minus 4 minus 1. Means repetitively adding minus 1 we will get next value for output. Here we can say that the linear function is best suited for the given data. Another example, x and y values are given. Again 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. Okay. Then we predict based upon the output value. You can see here 11 minus 6, 5, 6 minus 3, 3, 3 minus 2, 1, 2 minus 3, minus 1. Difference is not same. Again we find out the difference. We will get 5 minus 3 plus 2, 3 minus 1 plus 2, plus 1 minus minus 1 plus 2. Here we get second difference as same, means constant second difference. Means here we can say that the quadratic function is best suited for fitting this given data. Another example, x and y values are given. X value increasing by 1 unit. You can see 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. But we can predict based upon the output value, that is y value. Okay, 3 into 6 into 3, 18, 18 into 3, 54, 54 into 3, 162. Means repetitively multiplying 3 we will get the next successive values of y. Means here we can say the exponential function is best suited for this given data. Another example, determine whether the data is best represented by linear, quadratic or exponential function. Again x and y values are given. Based on the output values we can predict. Here you can see minus 5 minus minus 2 will get minus 3. Minus 2 minus 1 minus 3. 1 minus 4 minus 3. 4 minus 7 minus 3. Means repetitively adding minus 3 we will get the next value for y. Okay, means we can say that this data is best suited or best fitted for the linear function. Another example, x and y values are given. Difference between the values of output we can predict. Okay, this difference 6 minus 3 plus 3, 3 minus 2 plus 1, 2 minus 3 minus 1, 3 minus 6 minus 3. No same difference. Again we find out the difference. 3 minus 1 plus 2, 1 minus minus 1 plus 2, minus 1 minus minus 3 means minus 1 plus 3 plus 2 means constant second difference. This is the first difference and second difference. Means here we can say that the quadratic function is best suited for this given data. Another example, x and y values are given. Based on the output relationship, 1.5 into 2 will get 3, 3 into 2 we will get 6, 6 into 2, 12 means repetitively multiplying 2 means here we can say that the exponential function is best suited for the given data. Thank you.